Hello and welcome back to another holistic education video. In this video, we'll be continuing our series on the 25 hardest SAT math problems of this year according to Prep Maven. In this video, we'll be looking at problem number 22, which says, a sample of a certain alloy has a total mass of 50 grams and is 50% silicone by mass. The sample was created by combining two pieces of different alloys. The first piece was 30% silicone by mass and the second piece was 80% silicone by mass. What was the mass in grams of the silicone in the second piece? So we're going to solve this by turning this problem into a system of equations based on the information we know. We know something about the total mass and we know something about the mass of the silicone. So we have two materials that we combine together to get a material with 50 grams and 50% silicone. So we know that our first material had some mass M1 and our second material had some mass M2, and when we combined them, when we added them together, we got a new material with 50 grams of mass. So we know that the mass of the first material plus the mass of the second material is 50 grams. Secondly, we know a little something about the silicone makeup of those materials. We know that the first material had an amount of silicone equal to 0.3 M1 because, of course, the first piece was 30% silicone by mass, so if we take the mass of that first piece, multiply it by 0.3, we'd get the mass of the silicone in that first material. And we know that the mass of the silicone in the second material is 0.8 M2, and if we add those together, we know we get the mass of the silicone in our final material, which is 50%, 0.5, of our 50 grams. And of course, 0.5 of 50 grams is equal to 25. So here we have two equations from the information we know from the problem, that M1 plus M2 equals 50 and 0.3 M1 plus 0.8 M2 equals 25. So to solve the system of equations, all we have to do is isolate for the value of M1 in this first equation, and then plug that value into M1 in the second equation. So to isolate for the value of M1 in the first equation, we just have to subtract M2 from both sides. So if we do that, and I will write that down here, we get that M1 equals 50 minus M2. So we've taken this first equation and we've rewritten it in a form to isolate M1, and now we can plug the value that we found for M1 into the second equation. So we have 0.3 times 50 minus M2, and of course that is just the value for M1 that we found here plugged in, plus 0.8 M2 equals 25. And we simplify this out, we get 0.3 times 50, that's 15, minus 0.3 M2 plus 0.8 M2 equals 25. We can subtract 15 from both sides here, and we get 0.3 M2 plus 0.8 M2 equals 10. And of course, we can combine these to get 0.5 M2 equals 10. And now all we have to do is if we multiply both sides by 2, we'll end up with M2 equals 20. So 20 is the amount of mass M2 in our second original material. Now, if we wanted to solve this full systems of equations, we could take this value of M2, we could plug it back up into this equation up here, and we could solve for M1 and get our value of M1. But that actually isn't necessary, because if you look at what the problem is asking us, the problem is simply asking us for what is the mass of silicone in the second piece. We actually don't need to know anything about the first piece. Now that we've solved for the mass of the second piece, we can answer the question directly, because it's asking us what is the mass of the silicone in the first piece. So if we take this mass that we found of our second sample and we multiply it by 80% or 0.8, we will get 16. 16 is our final answer, which corresponds to option number B. B is the final answer because by solving the system of equations, we found that the mass of our second piece was 20 grams, and we know from the problem that 80% of that mass was silicone, which means the amount of silicone in our second piece was 16 grams, or in other words, answer B. That's it for this video. Thank you so much for watching, and I look forward to seeing you in the next one.